Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. We are live from the SmartForce Student Summit at the International Manufacturing Technology Show. That summit, by the way, powered by AMT. Having a great week at IMTS, the largest and longest running industrial show of its kind in the Western Hemisphere. And it's been just a fantastic week to be with all of us, live streaming on YouTube for most of our episodes, recording several marquee episodes as well. So it's a great time for us to reflect on the history of the Tech Ed Podcast. We launched this podcast about 19 months ago, give or take, at the very beginning of 2021. And it's hard to believe we're now over 80 episodes that have been posted. We are streaming in 104 countries around the globe. We are on 43 podcast platforms. Today's guest, and he is, by the way, a member of what we call the Tech Ed Podcast Alumni Circle, and he is our first repeat guest on the Tech Ed Podcast. It is such a pleasure this morning to reintroduce to our audience here at the International Manufacturing Technology Show, the president and CEO of FANUC America, Mr. Mike Cicco. Mike, thanks for coming on.
Hey, Matt. Good morning. How you doing today?
I'm doing great. How's IMTS been so far?
Boy, you're gonna hear this is my Thursday voice. So I've had 3 days of talking to so many people, and it's been fantastic.
I think our listeners know that FANUC is the largest industrial CNC and robotics company in the world, and we don't necessarily talk about numbers and market share, but it is absolutely overwhelming. Every manufacturing company that I go into that's automating, the robots are yellow. Every single machining company, whether they've got FANUC robo drills or they've got other machine tools with FANUC controls on it. I mean, just huge market share. And we're going to get into some of the innovation that's going on at FANUC. But before we do that, some of the things that you've seen maybe outside of FANUC. So as you walk the show, I mean, you could spend 5 days here and not even see 10% of all the new technology that's here. But is there something that stands out, Mike, as you've walked through IMTS, outside of the work that FANUC is doing that you think is really interesting?
Well, one of the things that I think is fascinating and incredibly important, and it's where we're sitting right now. The viewers can't really see everything that's around us, but we are surrounded right now with buses and buses and buses of students that have been coming in from all over the country. And every IMTS, I can't remember how many IMTSs that we've done this student summit, but everyone has gotten bigger and better. And just walking around here today, that's maybe the first thing that stands out is that kids of all ages are finding a lot of joy in manufacturing, and they're coming here and their eyes are lit up and they're doing cool things, and I think they're bringing that back. So that's probably the first thing that I know that stands out to me is that just how powerful what we're doing down here. And then maybe the next thing is just stuff on the additive side. We've been dipping our toes into additive for a long time now, and I think this show is probably the first one that stands out to me of saying, all right, now we've got a real thing it's going to be a powerful part in our industry going forward.
Absolutely. And what's been interesting, I think it was Josh Kramer from America Makes on with us yesterday, and we were talking about, and of course, they're really focused on 3D and on additive. And I've seen an evolution on the subtractive manufacturing, the machining side of things, in terms of the attitude toward 3D. I think initially, if we turn the clock back, and I was here at the Student Summit, I think, for the first time in 2016, turn the clock back to that, there was a lot of concern, is this going to displace CNC manufacturing technology? Do we have to be worried that it's possible that we won't have the level of manufacturing on the CNC side in the future? And I think that for the first time, at least at this show, what I'm seeing is that even the companies that are all in on subtractive manufacturing are starting to see the applications for additive. And it's not an additive or subtractive. It's how do we combine the best of both? Oftentimes using FANUC controls, right, on a machine that can 3D print. And so, do you feel that as well, that the folks on the machining side, machine tool builders and so on, are starting to understand, look, this is really complementary technology?
Yeah, I couldn't agree more with what you're saying there, and it's being able to actually see it in some of the subtractive machine tool builders' booths. 3D printing and additive was always thought of like, all right, we're going to prototype stuff with it. It was always kind of a tinker, and now it seems like it's in production, but it's a complementary to subtractive. That I'm going to machine something, I'm going to add something to it to make it more useful, and then I'm going to machine that off again. And I think everyone's embracing it quite a bit.
It is. So this show has been all about growth. To the earlier question, you're talking about the growth in the SmartForce Student Summit. Thousands and thousands of students coming through here today, seeing new technologies, and I think you're exactly right. And it's, every year this thing grows a little bit. It feels to me, as someone who has spent 25 years running manufacturing companies here in the United States, that we're turning the corner in terms of an interest and an understanding on the part of students and parents about the amazing careers, just incredible careers that exist in manufacturing. Certainly those exist at FANUC as well. And so growth at IMTS, growth in the students, growth in the world of additive, and growth in the world of FANUC, right? I mean, so let's talk a little bit about that. You're expanding your Michigan campus, and it's expanding to 2 million square feet. Almost hard to fathom. When you and I started working together, you had 2 major expansions, and now I was talking to one of your vice presidents yesterday, and the question isn't, is FANUC expanding? It's, which expansion are we talking about now? We were kind of joking about that. So it's almost hard to wrap our brains around a 2 million square foot campus dedicated to advanced manufacturing, CNC controls, and in your case, certainly robotics, and both on the distribution and on the manufacturing side, being one of the few, if not the only, manufacturing company that's actually building production robots here in the United States. So tell us about this project and what is driving the need for the expansion.
Yeah, sure. I mean, so within FANUC, you mentioned a number of the different things that we do, and I think it's important to understand that we are the only robotics manufacturer that is building a ground-up robot in the United States of America, in Rochester Hills, Michigan, and the growth in that business. We build all of our painting robots in Michigan, and we're FANUC's only supplier of those, and so we build them in Michigan and we export them all over the world. And we're seeing a tremendous growth here domestically in the U.S., but also a tremendous growth overseas, both in China and in Japan. And so we have seen that business double over the last few years, and we need to plan for it to double again. So that's one of the biggest drivers is we need to create more floor space to increase our manufacturing capabilities. As you mentioned, we're up to about 2 million square feet, but the property that we purchased, it's about 67 acres of property. And what we actually bought was a law school called Cooley Law School. It was part of Western Michigan's campus, and unfortunately, it went out of business. That particular campus went out of business. But we bought a fully functioning school.
Yeah, awesome.
And what a better chance, a better opportunity in buying a school than to increase our dedication to the education market. And so we're going to open up a new campus for our FANUC Academy, where we supplement all the work that's being done within the school system. The FANUC Academy teaches the same curriculum, but we do it for our customers, we do it for our employees, and it's all the same things that we're putting into the schools today. So we're going to use that as well.
Yeah, and I think that's an important distinction, and we'll get into that and some of the great things that your Executive Director of Education, Paul Aiello, is doing in the education space in a little bit. But when you talk about the education that you're delivering to a high school student, to a technical college student, even a university student, as we sit here at the SmartForce Student Summit, that is exactly the same competencies, exactly the same skills that you're teaching to your industrial employers and to their employees, which really kind of creates that seamless transition from the training program in the high schools, in the technical colleges, and so on, right into industry, because it's exactly the same curriculum. Really, really exciting, and it is FANUC America, right? It's not FANUC United States. America, certainly in your case, includes Mexico. Tell us about that expansion and what's going on in Mexico.
Yeah, sure. I mean, the relationship between the Mexican manufacturing market and the U.S. manufacturing market took a little bit of a hit as we call it new NAFTA, but as new NAFTA was being considered. And now that that's in place, I think the trade relations between the U.S. and Mexico are really strong. The Mexican market's always been a really big market for us. There's a tremendous amount of manufacturing that goes on down there. And even though the labor market's a little bit different than in the U.S., the need for increased quality, increased safety, increased productivity, all of that still holds true in the Mexican market. So the center, our headquarters, the center of our business down there is in Aguascalientes, in the center part of Mexico. There's a tremendous manufacturing base there, and we just saw the need to be able to offer more training. So part of our this expansion includes probably a quadrupling of the training area that we have for our customers. down there, and then just more floor space as well. So we have 3 offices, Monterrey in the northern part, and Querétaro, that's another good Spanish word that you can say. Querétaro is in the southern part of Mexico.
For us here on the Tech Ed
Podcast.
Right.
So really strong business base in Mexico. Almost 200,000 square foot on our new headquarters there.
Got it. I had a great trip to FANUC. It was about a month ago. We had some relatively high profile folks from my home state of Wisconsin that wanted to learn about. So they knew about automation, but they wanted to see it applied, and they really especially wanted to understand how do we train this next level of Industry 4.0 and automation and talent, especially when it comes to robot operators, robot programmers, robot technicians, and so on. And one of the things, there's a couple things, actually a lot of things I love about visiting your facility in Rochester Hills, in addition to seeing all the growth. The first one is that you're always so gracious with your time and with your team, and so thank you very much for that. Secondly, we get the opportunity to walk through your customer experience center, and if folks have never seen that, they need to go. I mean, it's just that you'll see applications of robotic technology that'll just blow your mind. Vision systems, the speed at which a M1AA robot will move, pills around. It's just every single time I go there, it's a treat to be there. And then the third thing is you're always pretty good about, kind of letting us look under the hood a little bit. And I know there's things that you can't talk about with regard to R&D and advancing your technology, but you're always really good about walking us through the R&D area. You have a huge commitment to research and development at FANUC, both in Japan certainly, but here in the United States as well. So tell our listeners a little bit about what's going on in R&D, how you think about R&D, kind of where are you in that space?
Yeah, it's a good question. Within FANUC, as you mentioned, we have a very strong commitment to R&D in our Rochester Hills headquarters, and that goes back to the joint venture that we started with General Motors back in 1982 when we were founded. The team of developers that came from General Motors partnered with a team of developers from FANUC in Japan, and we started developing robots together. And so we've maintained that group of development engineers for the last 40 years. In addition to that, now we have an office in Union City, California on the West Coast, and now we've started an advanced research laboratory with those engineers there, and most of those are actually PhD scientists. They're dreaming up new ideas for the way future.
In what disciplines of engineering, if I can ask, are those folks?
It's mostly in software,
okay.
And then a little bit of hardware in the grasping area of robotics that we have there. Most of them are from prominent universities, a lot from Berkeley, just because it's in the area. FANUC has a strong partnership with Berkeley and many others. But one of the things I would say is that in terms of the overall development mindset, one of the things that we're really focused on is artificial intelligence.
Okay. Yep.
And that's a word that gets thrown around all over the place. I can spin it into a bunch of different ways.
Sure.
But the way I categorize it, the way we're using artificial intelligence or AI is we need to take things that are really, really technically challenging, like 3D bin picking a random bin full of consumer products, and make that extremely easy for somebody to program and teach. And you need to have artificial intelligence or AI to be able to do that. So there's a lot of, without getting into too much specific details, the under the hood stuff, that's a lot of what goes on behind the closed doors in our development area.
I think that what's happening is as that relates to vision technology and the combination and really the emergence of both AI and vision technology, driving tremendous change in the world of manufacturing. So the way I like to explain artificial intelligence, and this isn't original, I stole it from a guy named Murtaza Bora, fascinating expert on artificial intelligence, but it's, we define intelligence by calling it human experience and learning. And so that's, if we think of intelligence, it's really our route through whatever we went through to experience life, and then what is our process for gaining additional knowledge. And the artificial part of it is really just, it's an algorithmic and mathematical expression and implementation of something. And an algorithm is just a list of computers or rules or codes that a computer uses to perform a task. So you put those two together, it's really just a mathematical implementation of human experience and learning is the way that we describe in artificial intelligence. What's happening, though, is we're combining that with vision systems, and I think this is really important for manufacturing. In my world of coding, right, if I had a bin of parts that came to a coatings line, trying to get a robot to find the part in a specific Cartesian coordinate, specific XYZ coordinate in that bin, pick it up, and then find the rack in exactly the right spot was nearly impossible. And I ran companies that we had 16,000 SKUs that ran through that company, almost impossible. Now you start, for our audience, and I think this is where you're going, you start combining that with a camera that can see just as well as a human, and intelligence that can discern the orientation of a part, an angle, a curve, and so on, find that part in a bin, put it in a machine tool, put it on a rack, and now there's all of these jobs that, quite frankly, aren't always the safest or most interesting jobs in manufacturing that we can automate and then free those people up through FANUC training to have really, really cool careers. Are you seeing it the same way?
Yeah. I'll give you another example. Up in our main booth in the South Hall here at IMTS, we have a demonstration where, for a person, as you mentioned, it's your experiences and how you apply that. The application is taking a tire and putting it on a car while it's moving.
Right.
So, and for a person, that's a lousy job actually, because tires are heavy, and so we're trying to figure that out.
Right.
But in order to do that, the tire's going to come down in any orientation, so you need to find that in 3 dimensions. The car's moving, but it's not located perfectly every time because it's sitting on a pallet. So you have to find the car in 3 dimensions and figure out how fast it's moving. Then the wheel hub is oriented rotationally in a different division. And then also, because it's on the front or back of the car, it can be offset as well. So we have a 3D sensor picking up the wheel. We have a 3D sensor to find the car. We have a 3D sensor to find the wheel hub. Then you need to actually use some force torque sensing to get it on the tire on, all while everything's moving at the same. And so you think about, number one, that a person can do that really without thinking about it. If I told you to go pick up that wheel and put it on a car, you probably could.
Right.
I mean, it might be heavy, but you could do it. But trying to teach a robot how to do that, there's a lot of stuff going on there. And so we took one of our, she was an intern for 2 years, and then she just started on permanent. Jennifer's her name. And we put her on that task. And using all the tools available to her, she was able to do that. And it turned out great. It's a really slick demo if you have a chance to go check it out.
Yeah, absolutely. I mean, the FANUC booth here at IMTS, it has to be seen to be believed. And you outdo yourself every single year. And it's not just the booth, but I'm telling you, Mike, as I walk around this show, all you see is FANUC robots. I mean, it's absolutely, I don't know how many are here. Maybe you do, but it's. Do you happen to know that number?
There's a lot, 200, over 200. I can't remember the exact number, but over
absolutely,
200 robots
absolutely
out there.
Incredible.
Yeah.
Another huge advancement in the world
right.
of robotics, we teased it a moment ago, is this whole world of collaborative robotics. And I just, for whatever reason, I just remember this moment when several years ago, I forget exactly how many. I think it was pre-COVID, that FANUC released, or at least announced, the first CRX, and I texted you that day, and you were on a plane coming back from Japan, and I said total game changer, and that was just the text, and you responded, and it really has been a game changer for FANUC. You're really methodical and deliberate about your development. Weren't necessarily first to the space in the collaborative space, but probably best to the space in the collaborative space. So tell us what's going on in the world of collaborative. I know every time you turn around, you're introducing another CRX, another version of it, another application. What's going on there?
The original technology that was out in the marketplace from some of our competitors, we saw that, and as you mentioned, we weren't first to the market in this, but what we really wanted to focus on is how do we industrialize it. One of the things that FANUC stands up on our name is with our reliability. And we wanted to make sure that if we were going to come out with a collaborative robot like the CRX robot, that it was something that was going to last in a factory environment, but also provide the benefit to the user that really inherently comes with a robot like that. The word collaborative robot, it inherently means that it works in and around people. You can collaborate with it, and there's always a big benefit to that if it touches you, it stops. But for the most part, you don't want the robot to touch you. I mean, that's like kind of the emergency part of it. The real benefit that I'm seeing in collaborative robots is just adding another big group of accessibility into companies that can use robots and automation. It is enabling small to medium-sized businesses to really step their foot into the automation space, because one of the big challenges that industry has is there's a low volume and a high mix, and that's always been one of the big challenges. And we can solve that with an industrial robot by putting a bunch of sensors and vision and AI, but that's hard for that gets hard for a small business to do. And the collaborative side, really what it does is it 8 o'clock in the morning, you could teach it to do one thing. By noon, you could teach it to do another thing. And you're seeing that all over. I just stepped through one of your booths here at the show, and there was a freshman in high school teaching a robot how to pick up a ball and move it around, and it's amazing. So, I mean, if these kids can do it, someone on the factory floor can do it. And so I think that's one of the biggest things that the CRX brings to the market is that level of accessibility into it. And then, like you mentioned, then once we figured out the technology on how to put the sensors into the arm, how to make it reliable, Then we started scaling it. So now we have 5-kilogram version, a number of 10-kilogram versions in different lengths, and then the latest one we came out with is actually the biggest collaborative robot in the market. Is a 25-kilogram CRX robot. That's a really big robot that's great for just simple palletizing.
So we talk a lot with small to mid-sized businesses, and that was the space that I was always in. I was never running a $40 billion or billion-dollar manufacturing company. I was usually sub $50 million. A couple hundred employees, those kind of things. And it was this, so I get this question a lot from manufacturers, and they'll say, look, I'm not Intel, I'm not Volkswagen, I'm not General Motors. You come up with all these great examples of how they're deploying automation. That's fantastic. My automation budget might be less than $100,000 a year, depending on the size of the company. What am I supposed to do? And especially as you talk about with that high mix, low volume, and for our listeners who may not be familiar with that term in manufacturing, it means that I've got lots of different SKUs, different types of parts that I'm running in low volume. So I may get, it's not like I'm putting 100,000 wheels on cars every single week. I might get a lot size of 20 parts, right? And I get that order once every 6 months, and I have to run 20 parts. And the cost of automating that with a traditional, 6-axis robot or Delta robot, really, really expensive. In part because you've got to come up with a whole program. Now you've got lead-through programming, you've got accessibility, to your point, and so small to mid-sized manufacturers now have access to this technology. Is that a pretty significant part of your growth plan? Is getting at those small to mid-sized businesses with automation solutions?
Oh, absolutely, yeah, and we've seen it happen. And we're here at the IMTS show for manufacturing technology, and you see a lot of job shops and things like that here, but it grows beyond that as well. I mean, in consumer products and food and beverage, there's small shops all over the place. There aren't just people that are cutting things out of metal or molding things out of plastic or 3D printing things. I mean, there are shops all over the place doing a lot of different things. Even one of this might be pretty relatable to people, but what's called co-packing. So you go to Starbucks in the morning and you see that little package at the bottom that has a hard-boiled egg and a little sandwich and something else in it. That doesn't magically happen that way. Yep. Someone's putting that egg in there and putting that little sandwich in there, and those are the types of things that during the pandemic, when you went to Starbucks and there weren't any of those there because there's a labor challenge and there's health and safety issues, those are the types of things that I think need to be automated, maybe as a perfect example of a low-volume, high-mix opportunity for us.
Absolutely. Mm-hmm. So we've talked about collaborative robotics. We've talked about artificial intelligence. Other technologies that you see shaping the world of automation and robotics, Mike, in the coming years, without giving away any secrets, what are you kind of thinking about when you wake up at 3 in the morning?
Well, one of the things that, again, you'll see in our booth is the idea of digitization of things. A lot of people call digital twin is a word that gets used quite a bit, and the way I see that part, the speed to market is a really important thing. Is how fast can you have an idea, get it built, and get it into a factory to have it actually start being relevant. And that's something that is really important. Even if you looked at the EV space, where if you could snap your fingers and have your next car being produced right now, the investment and the money that's in that market right now would be really useful for them. You hear a lot of these current EV companies going through a lot of struggles with their initial production.
Right.
So being able to digitize what you want to do and do it offline or without worry about crashing something or breaking something is really important. And that's something that we're working pretty strongly towards. We've done a lot of that on the robotic side for a bit, but now more and more we're digitizing the inside of a machine tool using a FANUC control. So we're using a real FANUC control. We're digitizing the output of that into a system that then replicates the way a machine would move, with graphics that absolutely blow my mind because of how hyper-realistic it is. So that's some software that we have. That's something that I see is digital twin, seeing the digital representation of things, all with the idea of we want to get them into the factory faster.
Yeah, the way I put it is historically the scariest day in the life of a manufacturing engineer. Scariest day in the life of a manufacturing engineer is the day we change the process, right? On the shop floor. So, you've got a process that's been running really well, maybe 2, 3, 4 years. Somebody's like, hey, we have a continuous improvement project, a Kaizen event. There's a better way of doing this. And so we come up with this better way of doing it. And now we've got to make the change. And we turn the switch. And if it works, everybody's like, oh, yeah, well, that's your job.
Sure.
And if it doesn't work, now you're shutting a line down. Now you can't produce parts. Now you've got a customer that can't run their production line. Scariest day. So what happens now when we can automate that process where we can test out on the digital twin as opposed to on the actual process, and we can innovate there, and that is going to drive innovation in the world of manufacturing like crazy.
Yeah, absolutely. You can imagine on that your shop floor, whether it's cutting metal parts or producing plastic parts or anything that you do, that's still going, and everyone's still doing that. And behind the scenes on a computer, somebody's innovating and developing the next thing. And you're doing that with a high level of confidence that it's going to work when you actually implement it, because you have that you have a twin, you have a digital representation of exactly what you're doing, and so once you're done with that, you just transfer it over and it should work, and it does, and we've seen that happen.
Yeah, good friend of yours, Blake Moret, the chairman and CEO of Rockwell, was on last year talking about his investment in Emulate 3D as just one example of this digital twin software and
That's
where
right.
it's going.
And truthfully, it's actually a good point that Blake and I mean, the two of us talk, but we didn't actually do this together, but our teams did,
right?
Where with Emulate 3D, we created a RoboGuide plugin to that, so that Emulate 3D emulates a Rockwell PLC and,
right,
and does it offline. But most of the time with a Rockwell PLC, you've got a robot around there someplace.
Absolutely.
And so we created a link between our emulation software called RoboGuide and theirs with Emulate 3D, and now you have a link between the two where you have real-time PLC control built in, and then real-time robot control built in on the other side. So
Such
it's
a fascinating time to be working in the world of manufacturing technology. We've got two more questions for you, Mike. I know your time is valuable. Really appreciate you spending all the time with us today. The first one is around education. So FANUC was really, when we talk about being first to market with a really turnkey education program. You saw the need way sooner, I think, than many others, and made the investment way sooner in understanding that if we are going to continue to grow, if we're going to implement this type of technology in manufacturing, we have to have a workforce that understands it, is comfortable around it, can program it, can operate it, can service it, and really, and I've given you credit for this many, many times, but for that foresight in getting to the education market early, your team, including, Paul Aiello, who's a great friend, and John Potter and Wendy and so on, really great folks working in the education space on behalf of FANUC. So here's the question. Your FANUC CERT program has transformed manufacturing programs in education. I don't even, do you know the number offhand? Is it 1,600 some CERT programs?
It's getting close. I know a top 1,500. I don't know the exact number, but it's a lot.
So when you think about that, 1,500 schools across the United States that are teaching FANUC robotics operations, FANUC robotics programming. So what's your take on the workforce? Are we starting to turn the corner toward having a workforce that's astute enough with these technologies to support the innovation that's going on in manufacturing?
Well, I'll tell you, so we talked earlier when you were talking about collaborative, is that we weren't first to the market, and FANUC, it does have a mindset of when we're going to do it, we want to do it right. But when it came to education, that was something where we needed to be first. There was no hesitation. There was no wait and see what someone else does and try to do it. It was a very direct, deliberate, huge movement towards it. And I've told this story many times. It struck me first with my own children. I have 4 children of my own, and they obviously know what I do for a living, and so I asked them a lot of questions when are you starting to learn about what I do for a living in manufacturing in school? When are they talking to you about that? And they said, Dad, that what I learned in school is how Henry Ford built the Model T.
I know,
and I learned about it in history class, and that's the only type of manufacturing training or education that I got. And so that struck me very, very near dear to my heart. Plus, just seeing the challenge of finding employees in our own company. So we started hot and heavy in that. And thank you for the comments, and thank you for the support, because it has been very successful. And it isn't and doesn't need to be financially successful. That's not the point of it. It's successful because we're touching young minds and we're re-educating the existing workforce. It's not just there's a lot of young kids in here learning it, but the re-education of an existing workforce is just as important, and we're doing that. And to me, that you asked the question of are we turning the corner? Every time FANUC hires new people, I host a seminar to them, an opening kind of welcome statement. Here's our history, here's our culture, welcome, and we want you to work here for a long time. And truthfully, I used to do that thing like once a quarter, and now with the amount of people that we're hiring, I'm doing it like every couple weeks. And for the last year or so, I started asking a question during that, and I said, who here touched some level of a FANUC robot or a FANUC CNC in school, whether it was in high school or a 2-year tech or in a university, because we hire people from all of those realms. And 100% of the time in the last year, somebody in the crowd has raised their hand and said, I've used a FANUC product in my training or in my education, and to me that means we're turning the corner. I would love it if I segregated out all the people that we're hiring from a technical perspective, that 100% of them raise their hand
right.
and say that that's going to be the ultimate goal. But knowing that someone in that group raises their hand every single time means that we're turning the corner, and those 1,500 schools are doing their job.
Yeah, it just gives me goosebumps because here at the Tech Guide Podcast, we talk about securing the American dream for the next generation of STEM and workforce talent. And what you're telling me is that all of those efforts in technical education and advanced manufacturing education, that they're paying off, and they're paying off in the numbers, and they're paying off in actual students who have now found their way into careers in manufacturing through experiences that they had while they were in middle school.
Yeah,
and
that's
high
right.
school.
And like you just said, it's not just that they touched it in school. It's just that they chose the path on
right,
top.
Exactly.
They touched it and got turned on enough by it that that's the path that they chose, and ended up with us. And I'm just imagining how many other companies around the world, if they'd asked that same question, they'd get the same result.
So it's probably a great segue into the last question that I have for you, Mike. Now, you were one of the very early guests on the Tech Ed podcast. In several episodes after you were on, we started asking every single guest the same question. You never got an opportunity to answer that question, so we're going to give you that opportunity now. And that is, as you think about a young student, the students we were just talking about, as they're in high school, let's say a high school sophomore, 15, 16 years old, thinking about their future, thinking about their career, what advice does Mike Cicco, President and CEO of FANUC America, have for that student?
Figure out what you like to have fun with is probably the best thing I can say is that if you can't have fun in your career, it's going to be a struggle every day. You hear people say, I got to get up and go to work again or whatever. But if you get up and have fun every day, then you enjoy it. You enjoy going to work. And it's something that I'll tell you a quick story about early in my career. So I've been at FANUC for 23 years. But before that, I worked at Northrop Grumman outside of Baltimore for a couple of years right out of school. I went to Bucknell University in Pennsylvania. And within there, I was doing a lot of stuff, a lot of confidential stuff I can't talk about. But we worked on a job for the post office. And we actually lost that job, and we lost it to FANUC. But during that job, I was offered the opportunity to go to Michigan and learn how to program a robot. It was actually an ABB robot, one of our competitors, that we were using on that job. And I never had so much fun in my life that I chose electrical engineering as a career path for a lot of reasons, and I liked coding. I liked sitting down in a computer and writing code and seeing the outcome. But that was all digital, so you type some stuff and something happens, a light turns on or something. But when I got to realize that I could write code and something huge could move really fast, and it would move exactly where I programmed it to, man, I just thought that was the best thing I've ever seen in my whole life. And that was it. That was my turning point right there, where I knew that was the career I wanted. And so I chose that path. I started working as a software engineer for FANUC in California in 1999, and I got to do something that was a lot of fun. And me and a bunch of my buddies out there had a lot of fun. We're stacking boxes of jelly beans at Jelly Belly Jelly Beans. We were handling big totes of bread at King's Hawaiian Bread Company. So, man, we had a lot of fun. And so now that fun kind of translates into other things. And truthfully, my fun today is influencing other people. And so I don't get to program robots the way I used to anymore, but my fun is being able to look at the entire industry and set a direction, and seeing all the yellow robots around here at schools. And I feel like FANUC and I had a part of that. And so that's really what drives me now today. The one thing I want to add that you mentioned it, and I think this is important because I do have kids in high school right now and they're figuring this out. I think if there are any kids listening to this, you don't have to figure out what's fun today. That's a really important thing that right now, for whatever reason, we're pushing our kids so hard that they need to figure things out like when they're a sophomore. That is not, absolutely not. I changed majors in college 3 times. And as I mentioned, I went and worked for a defense company for 2 years before I realized what was fun. And so it's a journey, and you got to enjoy every step of the way. And then sometimes things that you thought were fun stop being fun, and you need to go find something else. So I think it's important to know that there's no pressure. You figure that out step by step.
Just really, really good advice for a high school sophomore. Good advice on all the things we've talked about today. Technology and manufacturing, Industry 4.0, collaborative robotics, artificial intelligence, FANUC expansions. Congratulations. You guys are on fire. You're doing great things. Thanks so much for taking time out of a really busy week to be with us on the Tech Ed Podcast.
Absolutely. I wouldn't miss it. Thank you so much for the opportunity. Thanks, Matt.
Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you liked this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.